Hi everyone, I'm Steve Tobin, an applications engineer here at Instron, and in this video, I'll be providing a general overview of our environmental chambers. If you're like many of our customers, your materials or products are likely expected to offer reliable performance in a wide range of environments or temperatures. This often means that you'll need to run your products through a battery of mechanical tests at non-ambient temperatures. This is made possible by using an environmental chamber, such as the one seen here, which can be used for testing anywhere from -150 to +600 degrees Celsius. Chambers come in a range of sizes to accommodate the space requirements of different static and dynamic testing applications. Instron offers a range of temperature-rated mechanical, pneumatic, and hydraulic grips in various sizes and load capacities for testing all types of materials. We also have a number of temperature-rated fixtures, including compression platens, bend fixtures, and many specialized composites testing fixtures. The use of a chamber does change up the load strength slightly. Instead of connecting a grip or fixture directly to your load cell, we add a pull rod, which gives us the extension we need to have the proper reach and separation inside the chamber. I also want to highlight how important it is to set your physical limit switches to avoid any costly fixture collisions within the chamber. When adding a chamber to a test system, there are a few important considerations to review to ensure a smooth installation. First, let's discuss chamber mounting preferences. One option is to fix the chamber directly onto the load frame. You'd likely want to do this if you intend for this to be a dedicated system for non-ambient testing. The other option is to use roller mounting brackets, which we have set up on this frame. This is usually the more popular option, as it provides the flexibility to move the chamber out of the test area when not in use. Moving the chamber is easy. These wedges are removable to allow the chamber to be moved without having to dismantle the load string. After removing the wedges, you simply slide the chamber out of the way. Whether you opt for a fixed in-place chamber or roller mounting, it's important to consider the additional space requirements. For a fixed chamber, you'll want to make sure you have at least 300 millimeters of available room behind the frame to accommodate the gas lines and supply hoses. More space is required for a roller-mounted chamber. If you have a table model, you'll need to account for approximately 900 millimeters of additional space behind the testing machine, and it's around 1400 millimeters for floor models. These are approximate figures that are dependent on the specific configuration of your system. It's best to refer to Instron's pre-installation manual to confirm the exact space requirements for your frame and chamber. All chambers are available in 200 to 240 volt single-phase power. Some chambers, intended for use on table model systems, are also available in 100 to 120 volt single-phase power. Your chamber's specific power requirements and connector type are in the manual. All Instron chambers have a heated, optical quality glass window to minimize frosting and misting when testing at low temperatures. This allows the use of our AVE2 video extensometer for strain measurement through specimen failure. The AVE2 records images of the test, which can be used for synchronized playback or post-analysis using digital image correlation software. We recommend the AVE2 with the chamber because of its ease of use, its ability to be used through break on all types of materials, including high elongation materials, and since it sits outside the chamber, it has higher temperature limits. Alternatively, instrumentation ports are present for the use of temperature-rated clip-on extensometers, including biaxial, transverse averaging, and crack opening displacement gauges for fracture mechanics testing. Inside the chamber, we have a light that makes it easy to see the specimen when the chamber door is closed. There are also fans that circulate the air to bring the chamber up to temperature quickly, provide thermal stability, and reduce thermal gradients. The fan speeds can be set to high or low. Low speed is often preferred when testing delicate specimens where you'd want to reduce the effect of air turbulence within the chamber. For below ambient testing, there are two coolant options: liquid nitrogen, LN2, or carbon dioxide, CO2. LN2 is usually preferred because it allows for testing at lower temperatures, it's more readily available in larger quantities, and you need to change the canisters less frequently. CO2 is occasionally a better choice for some applications, as it has the benefit of being able to be stored for longer periods of time without loss. It also offers higher cooling power, which enables the chamber to reach the required temperature faster. Whether LN2 or CO2 is used, exhausted gas is output through a dedicated port in the rear of the chamber. A silicone rubber pipe can be attached to this port to vent the gas away from the laboratory. We recommend consulting your local rules and regulations for how to properly vent this gas. There are two ways to select the set point temperature. One way is with the temperature controller on the chamber. The other is to set the temperature in the Instron software, which allows you to create a test that will ramp to a set point temperature and pre-soak for a designated period of time. It's also possible to set temperature ramps and holds within a test method. The live temperature display makes it easy to monitor the temperature throughout the test, ensuring precise and accurate temperature control for all your non-ambient testing. And that's a high-level look at our environmental chambers. For more information, please contact your local Instron sales engineer or contact us at instron.com. Thanks for watching.